Hey everyone, welcome to your brand new playlist on Numpy Library. Now, in this Numpy Library video series, we will go in depth in Numpy Library to help you begin your learning journey with Python for data science. Now, when we talk about this Numpy Library, one of the main things that we'll always be looking out is how we can perform the mathematical operation on a given data set in an efficient manner. And NumPy is a library which will help us to do that in an efficient manner. So as we progress in today's session, we'll understand what is NumPy and why do we actually need it. And then we'll look into a simple procedure as how we can install this NumPy library. Next, we'll go ahead and we'll look into the types of arrays. Then we'll compare between arrays and list. We'll look into the Python list and we'll also compare nested list versus 2D arrays. And as we proceed in this video, we'll also look into the concepts related to speed and the memory allocation and what it actually means by contagious memory allocation. And at the end of this video, we'll also look into the concepts related to how we can represent the array data. Yes, how we can represent the various types of array data. So that's how our learning journey will be in this video. I hope you guys are as excited as I am. So let's get started and let's start by understanding what exactly is this NumPy and why do we actually require this. Now NumPy is also known as numerical Python. Now this is a library which consists of multidimensional array object, and along with that it consists of the set of functions which will help us to manipulate this multidimensional array object, and that's the role of this NumPy. And this NumPy, guys, it's a Python scripting language. Now if I'm working with this NumPy, it clearly says that I'm working with one of the powerful object that is present in Python library, which will help us to perform the operations on our data in an effective manner. Some of the main features of this NumPy library are it supports scientific computing. It has various functions which will help us to perform the advanced mathematical operation. The best part is it has very limited code requirement because we've got all the various functions which are present inside my NumPy library to do all this operation. And using the operations and performing the operations on top of this NumPy arrays, it's actually easy even on the larger number of data. Hence, I would say that NumPy library is more efficient when it comes to performing the mathematical operation compared to the inbuilt Python sequences like dictionary, list, sets, and so on. But one key thing that you always have to remember while working with this NumPy library is NumPy library is composed of the arrays, and this array can contain single data type. That means we say that arrays of homogeneous data. So this is what a NumPy is all about. It's a library which has the important object that we call it as an array object, and it has various functions which will help us in manipulating them. Now, in order to work with the NumPy library, we have to first install it. One of the main prerequisites to work with this NumPy library is the Python itself. So if you do not have Python, I recommend you to install the Python with the help of Conda, or you can also make use of Google Colab where everything comes as pre-installed. If you are using Conda, then you can make use of the command pip install numpy. This will install the NumPy library in that particular instance. So this is how you can install the NumPy library. Now once the NumPy is installed, you can get started, and one of the normal way that we import this NumPy library is with the shorthand notation as NP. For example, if I want to import my NumPy library, I will say import NumPy as NP. So this is how we import the NumPy library. Now, when it comes to this NumPy arrays, here we actually create an object, and this object will have the data type of numpy.nd array, which is nothing but n-dimensional array object. Now, if I want to create an n-dimensional array using NumPy library, we make use of a very simple function that's called as numpy.array function. Now, as I mentioned already, guys, when I'm creating an array, so this array can contain the value belonging to a same data type. I cannot have a NumPy array which is composed of multiple data type. I can create an array which contains a single data type. And once I create my array, I can perform the element-wise operation using various mathematical operator, and I can apply various functions which are present inside my NumPy library, and I've got various function methods and the variable to ease our task for performing the matrix computation, which is one of the important tasks, especially while performing the activity of data science. And thus elements of an array are stored in a contagious format. In order to give you an intuition as how does an array would look like, see, this is the representation of one-dimensional array. We've got the shape as 4 comma blank, and we've got the representation of two-dimensional array. Now here two-dimensional array is the matrix notation where I have the elements which are arranged in the format of rows and columns. And we've got three-dimensional array in the scenario of three-dimensional array. Here you can clearly observe that my three-dimensional array is nothing but array which is having rows, columns, and we also have multiple such rows and columns. Okay, so this is how we can visually get an intuition about NumPy array objects. Now you might be wondering, why are we using this NumPy array? Why can't I use the Python list? Well guys, one of the main reason that we prefer to work with this NumPy array object than the Python list, because one, NumPy array consumes very less memory compared to the Python list. And even I can optimize the memory allocation if I'm able to decide as what will be the minimal amount of required data type. That means I can say that np.int8, and by specifying this np.int8, I'll make sure that I'll be having the minimum size possible if I know that the values are ranging between 0 to 256. Now that's the best part of this NumPy array, and this NumPy array is pretty fast compared to the Python list when it comes to performing any mathematical operation. And we've got a lot of functions, and we've got operator overloading facility. As a result of this, it's very convenient for us to use. Now thinking about this Python list. Now as you know, this Python list is a collection which is an ordered and changeable. That means it's an ordered and a mutable data type. And this Python list are written inside my square brackets. So this is an example where a Python list has been created and the elements are represented within square brackets. And you can see that this is a list of integers. Okay, I hope it's clear now. So moving on. Now let's look at some of the important points that you need to remember about this Python list. Now the reason that we prefer NumPy array over this Python list, because here when you talk about Python list, okay, the Python list can be homogeneous or it can be heterogeneous. Now because of this, it consumes a lot of memory. So because of this, my interpreter has to do the additional work in order to decide as what are the elements that are actually being stored in my Python list. And here when it comes to Python list, the operation with the elements is not possible on the list. For example, if I want to add all the elements which are present in my Python list, I don't have a straightforward way. I'll have to make use of looping statement or list comprehension to do this activity. Moreover, even if I want to add a specific element to my Python list, it's not supported. Now when I say list plus 4, then in such scenarios, list doesn't support list plus integer. And you might be wondering, why should I use the NumPy array when I have a list inside a list, and that would give me a two-dimensional array representation, isn't it guys? Well, the reason that we don't use that approach, the reason that we prefer this NumPy library, because even I can create an n-dimensional list, but then it will still be a one-dimensional list storing another one-dimensional list. And that is the reason we prefer NumPy over Python programming language. And most importantly, it's because of the way my elements are stored. Here, when it comes to Python list, see the elements need not to be contiguous in memory. But when it comes to NumPy array, in NumPy array, it makes use of contagious memory allocation, which means the consecutive blocks of memory is actually allocated to a file or a process. And as a result of this, we are going to get a quick processing. Yes, we are going to get quick processing of our data set. So this is a special feature which we observe for the NumPy arrays. Now, when we talk about this NumPy array, as I mentioned already, in order to work with this NumPy array objects, first we will have to import the NumPy library. Now here in this cell, I have imported my NumPy library, and then in order to create an array object, we are going to send the Python sequence inside the parenthesis of np.array function. And you can see this is how an array would look like. Now if I want to create a two-dimensional array, then I just have to send list inside my list inside this np.array function. So as part of a learning journey in this video, you now have an introduction about what exactly is this NumPy library and what's the advantage of this NumPy array over Python list, and why do we prefer to work with this NumPy array. And guys, this is one of the most important library that you have to learn. The reason because this acts like a foundation for you if you are in the deep learning and when you want to work with the tensors. So the tensors are very much similar to NumPy library. So understanding this NumPy library will give you an edge when it comes to your data science preparation. I hope you like this video, and guys, follow us on YouTube, and I look forward to seeing you in our next tutorial, and it will be released soon. So thank you so much for watching. I look forward to seeing you next time.